Hello, ladies and gentlemen. Today we're going to solve a problem involving simple electrical circuit. Let's get started by reading the question together. Figure shows a circuit diagram comprising three resistors, a switch, and a battery. When the switch K is in an open position, the battery outputs 6 amp of current. What is the amount of the current that flows through the switch K when it is closed? Okay, when switch K is closed, there going to be no current going through here, as if this part of the circuit does not exist. So where the current will flow? Well, our 6 amp current will flow through R2 and R3, as indicated by these green arrows. So current starts off from the battery, goes here to this junction, passes through resistor 2, comes here, passes through resistor 3, and goes back into the battery. Okay, so effectively these two resistors are connected in series. And how do we calculate the resistance, the total resistance of two resistors that are connected in series? Well, it's just their sum. So total resistance of the circuit will be just resistance of this resistor plus resistance of this resistor, or 12 ohms. Okay, so we know the total resistance, we know the total current, and we can find the total voltage of the battery, right? Using Ohm's law, we can write down V equals I times R total, or 6 amps times 12 ohms, which gives us 72 volts. Now, what happens when we close a switch? When switch K is closed, now we can no longer ignore this part of the circuit. So what will happen to the current that comes out of the battery? Well, now the current, let's call it I prime, gonna split into I1 prime and I2 prime, meaning the current that's gonna go through the top part and the bottom part of the circuit. And once it passes through these two resistors, it's gonna combine back to the I prime, passes through the R3 or third resistor, and goes back into the battery. Now note that this I prime is not 6 amps anymore, right? Because we know that we didn't change the battery, so battery is 72 volts. We know the value of the resistances for each of these resistors. Now we can easily calculate what is the total current as soon as we evaluate what is the total resistance. But note, it's not going to be the same as 6 amps that we were given for the case of the open circuit, because now the values of the resistance of total resistance changed. Well, what is the total or net resistance of this network? Well, these two are connected in parallel with each other, and together they are in series with this one. Let's call the effective resistance here R12, okay? And it's in series with R3, so R12 plus R3. But what is R12? Since they're connected in parallel, when two resistors are connected in parallel, it's just R1 times R2 divided by R1 plus R2. And we have to add this one because this is in series. So since all of these resistances are 6 ohms, we plug in 6 ohm for each one of them, and we end up with our total resistance being 9 ohms. So if the total resistance is 9 ohms and the battery is 72 volts, we can easily find the total current, right? We're going to use the Ohm's law. So 72 volts equals to I prime times 9 ohms, or I prime comes out to be 8 amps. But the question is asking for the current that flows through the switch K, okay? So we are not asked for the total current, but the current that goes through this switch. Well, since these two resistors are connected in parallel, the voltage drop across them is going to be the same. So V1 has to be equal to V2. And what is V1 and what is V2? Well, we're gonna fall back and use Ohm's law again. So we have I1 prime, a current going through switch K, times R1 has to be equal to I2 prime times R2. Since we know the values of the resistances, we put 6 ohms and 6 ohms for each of them, and we end up with I1 prime being equal to I2 prime. And we know that I1 prime plus I2 prime has to add up to I prime. We already know that this is 8 amps. So I1 prime and I2 prime are equal to 4 amps. So the current that's going through the switch K is I1 prime, and it is equal to 4 amps. And this is the answer to this question. I hope everything is clear. Thank you.